Dear students, today we are taking the second chapter, Unit and Measurement. In that chapter, we are taking the accuracy and precision. So, accuracy. What is the accuracy? The accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity. So, accuracy, it is depend on the right method of taking reading. Accuracy again, it is the measure of how close the measured value is to the true value of the quantity. Whatever we are taking the quantity's value and we measure the value of the quantity, then how close we are to the true value of the quantity, that is known as the accuracy by using the instrument. Precision. What is the precision? Precision tells us to what resolution or limit the quantity is measured. Precision depends on the least count of the instrument. For example, your digital watch that shows the time as 10, 11, 12 am is very precise because it has least count of the 1 second. On the other hand, a grandfather clock has no second hand and it gives the time as 10:13 am. So the least count of the watch is 1 minute, which means that it is less precise. But if we take that the digital watch is slow, then we can say here that time measured with this watch has no accuracy, but it is precise. If the grandfather watch shows the correct time, then time measured with this watch has high accuracy but less precision. So, dear friends, we are taking the accuracy and the precision, in which in the precision it depends on the least count of the given instrument. So if you are taking the vernier calipers, then the accuracy and the precision is given by the least count of the vernier calipers, 0.01 centimeter. Same way, if we take the micrometer screw, for that we get the least count 0.001 centimeter. So between these two instruments, we can say that the micrometer screw is more precise than the vernier calipers. Now we are taking one example, that if the grandfather's watch shows the correct time, then the time measured with this watch has high accuracy but less precision. So physical quantity should be measured with high accuracy and high precision for any physical quantity. So for measurement of the physical quantity with accuracy, following steps are necessary. First, skill of the person doing the experiment. Second, quality of the instruments used. Third, the method used for the measurement. Fourth, external and internal factor of the experiment. Now, errors in the measurement. While measuring the physical quantities in a lab, some inaccuracies occur which must be mentioned along with the result. So, error, the definition of the error is the inaccuracy in measurement is called the error, or in general we can say that the inaccuracy of the measurement of the quantity is known as the error. So there are some classification of the errors. We can take the two type of the error. One, systematic error, and second, random error. First, in the systematic error there are the three types. One, instrumental error. Second, error due to imperfection in experiment technique or procedure. third, personal error. So error means what? If you are taking any measurement, suppose you are taking the measurement of the length of the some object, then if you measured it as a 2 centimeter, but actual length of the object is 1.98 centimeter, then the error produced by you, that is 0.02 centimeter. So this is known as the error. So error means inaccuracy in measurement is known as the error. So error could either systematic error or the random error. So now let us take one by one the systematic error and the random error, how the error is produced and what is the type of this error. First, now systematic error. Systematic errors are those error that tends to be in one direction, either positive or negative. Such errors cannot be both positive or negative simultaneously. So systematic error, this type of the error produced, then we can take the different observation, then in that different observation we get same type of the error repeated in one direction. Suppose if you are measuring the length, okay, then each time of the observation you get the 0.02 centimeter error repetition, for example. So systematic error, that is the errors which tends to be in the one direction. So some of the source of the systematic error are as follows. 1. Instrumental error. First, this type of the error arise due to imperfect design or improper calibration of the measuring instrument. For example, when no object is suspended from the spring balance, its pointer shows 0.1 gram instead of the 0. Then if you are taking the all the measurements, then all the measurements of more than true value will systematically contain this error during the experiment. So if object is 2 gram weight, then we get the measurement 2.1 gram. So we get the 0.1 gram more in the weight of the object. Now we are taking the another systematic error, that is the imperfection in technique or the procedure. So this type of the errors arise due to imperfection in technique or procedure by the person. For example, while measuring the temperature of a human body, any improper contact of thermometer with the body would produce an error in the measurement. External factors like the temperature, pressure, humidity can produce systematic error in the measurement. So if we are using the technique to measure the quantity by using any instrument, but there is a error due to this imperfect technique, then the error produced in each observation. So here we have given one example of the thermometer, that if you are not putting the thermometer in proper way, then you will get the error. Same way, another example, error due to the parallax, the contact reading and the correct reading is the 2 centimeter. When you hold the scale and your eye perpendicular in the straight direction, then you get the exact 2 centimeter correct reading. But if your positions are not proper, then you will get the incorrect position which is given in the figure. C. Personal error. Such an error arises due to an individual's bias, carelessness in taking observations, or improper setting of the apparatus of the experiment. This type of the error can be minimized by improving the experiment technique, selecting high quality device and removing personal bias. The random error. The random errors are those errors which arise due to irregular and unpredictable fluctuations in the factors affecting the measurement during the experiment. So this type of the errors can be both positive and the negative. Such errors can be estimated by taking many observations and then taking their mean or the average. So in the random error, it can be produced by any different external factors or the internal factors. Now the estimation of the error. First, absolute error and the average absolute error. The magnitude of the difference between an individual measurement and the true value of the quantity is called the absolute error of the measurement. What is the mean? If you are taking the 5 readings observation A1, A2, A3, A4, A5, then if you take the addition of these 5 reading and if divided by the 5 observation, then it known as the mean. So in general, mean is equal to A bar is equal to A1 plus A2 plus A3 plus up to so on plus An upon n. So it is known as the arithmetic mean A bar. And absolute error, the magnitude of the difference between an individual measurement and the true value of the quantity is called the absolute error of the measurement. Delta A1 absolute error is equal to A bar mean minus individual observation A1. If we do not know the true value, then the average value of the measurement is considered as true value. Suppose the values obtained in several measurement of the physical quantities A are A1, A2, A3 up to An, then their arithmetic mean is A bar, then A bar is given by the 1 upon n sigma Ai is equal to A1 plus A2 up to An upon n. So absolute errors are delta A1 is equal to A bar minus A1, delta A2 is equal to A bar minus A2 up to so on delta An is equal to A bar minus An. Now here delta A1, delta A2 up to delta An are called absolute error in individual measurement, which can be either positive or negative. So you will get the delta A1 or delta A2 either positive or negative also. The arithmetic mean or the average of the absolute error is called average absolute error. So average absolute error delta A bar is given by mode of delta A1 plus mode of delta A2 plus mode of delta A3 plus so on plus mode of delta An upon small n, where small n is the number of observation. In other way, we can write delta A bar, that is the average absolute error, is equal to 1 upon n sigma mode of delta Ai. So thus the measure of any physical quantity can be represented as A is equal to A bar plus minus delta A bar. It means small a is likely to lie between A bar plus delta A bar and A bar minus delta A bar. Second, relative or the fractional error. The relative error delta A bar is the ratio of the mean or average absolute error delta A bar to the mean value A bar of the quantity measured. So relative error or the fractional error is equal to average absolute error upon mean. Third, the percentage error. When the relative error is expressed as a percentage, it is called percentage error. That means if you multiply the 100 percentage with the relative error, then we get the percentage error. So percentage error is equal to delta A bar into 100 percentage is equal to delta A bar upon A bar into 100 percentage. So this is known as the percentage error. So dear students, here we have seen absolute error, average absolute error, then relative or the fractional error, and the percentage error. By using these types of the error, we can identify or measure the quantity's value, and we can get the result of the value of the quantity nearer to the true value. That's why we are using these steps of the errors, that is the absolute error, average absolute error, relative error, and the percentage error. Now we can explain this by using some example. So let us take the one illustration through which we can understand it. Now illustration is given. In the experiment, refractive index of the glass was observed to be 1.54, 1.53, 1.44, 1.54, 1.56 and 1.45. Calculate average absolute error, relative error and percentage error. Express the result in terms of the absolute error and percentage error. So first of all, we will find out the mean. So mean is given by n bar is equal to the total observations summation upon total observation, that is 1.54 plus 1.53 plus 1.44 plus 1.54 plus 1.56 plus 1.45 upon 6. So we get the n bar is equal to 1.51. This is the mean or the average. Now here an accuracy of the 2 digit after decimal point has been considered. So now the absolute error for each observation will be as follows: delta n1, delta n2 up to delta n6 we are taking. So delta n1 is equal to 1.51 minus 1.54 is equal to minus 0.03. Delta n2 1.51 minus 1.53 is equal to minus 0.02. Same way we get the delta n3 plus 0.07, delta n4 minus 0.03, delta n5 minus 0.05, delta n6 is plus 0.06. So this is the absolute error. Now we get the average absolute error or the mean absolute error. So by taking only magnitude, we get the delta n bar average absolute error is equal to mode of delta n1 plus mode of delta n2 plus delta n3 plus delta n4 plus delta n5 plus delta n6 upon n. So delta n bar is equal to mode of minus 0.03 plus mode of minus 0.02 up to so on upon 6. So we get the delta n bar is equal to 0.26 upon 6 is equal to 0.043 is equal to approximate we can write 0.04. Now the refractive index of the glass with absolute error n is 1.51 plus minus 0.04. The value of refractive index is between 1.55 and 1.47. Second relative error is delta n bar upon n bar is equal to 0.04 upon 1.51. We get 0.0264, that is approximately 0.03. It is the relative error. Percentage error is multiplied by 100. So we get the 0.03 into 100 is equal to 3%. So in general, we write refractive index of glass with percentage error is given by n is equal to 1.51 plus minus 3%. So in this way we can solve the example based on the error and we get the final resultant value. In the next session we will take the combination of error and the example based on it and significant figures and their rules. Okay, thank you.